Now we're going to do 8.2, number 42. This is also the volume of a solid. It's a little bit different idea because now instead of rotating, we're going to be creating our solid by stacking given shapes on the region. They still need to give us the region. In this case, they said we're going to start out with y equals e to the x-axis, x equals 0, which is the y-axis, and x equals 1. So we would still start out by drawing a quick sketch of what our region looks like. So in this case, again, here's x, here's y. Remember the x equals 0 is the y-axis. Here's e to the x, and here's the line x equals 1. So this is the region that what we're talking about. So I can shade it in yellow. I'm looking at this region right here. Then you have to read the problem carefully. That after you have your region, the problem will tell you how to create your solid figure. In this particular problem, they're saying that we are now going to take this region and we are going to stack on top of this region, we're going to stack semicircles. So in other words, I'm going to start right here. That would be the diameter of a semicircle. And I'm putting a semicircle sitting right there on that part of the region. And I'm going to move all the way along the region. So when I get here, that little line would be my diameter of my semicircle. And then I would have to stack it up like that. And all the way when I get to the end, where y equals 1, that distance from e to the x-axis is my diameter. And my semicircle would look something like that. So when I connect all of these little semicircles, I've created this three-dimensional region. Notice that the semicircles have a diameter, which is the distance between e to the x and the x-axis, and they're going to have a height as they go along that's equal to their radius because they're half circles. Each one of these cross sections, if I look at my figure, is going to be a semicircle. Their thickness is going to be here along the x-axis, so we would call that dx. And each one is going to have a little volume where it's the area of the half circle times its thickness dx. Although the size of the half circles change, there's going to be a pattern because I can explain exactly what's happening to the radius of each half circle as I move from x equals 0 to x equals 1. So in order to find out the volume, I would need to go ahead and integrate here. So I would go ahead, let's do it this way. I would go ahead and integrate from 0 to 1. I have half circles. I know I have half circles because the problem told me, and their thickness is dx. So I know that the formula for the area of a half circle is 1/2 times the circle, which is pi r squared, and then I still have my dx. So if I come back and look at my picture again, I notice that this right here is the entire diameter of the half circle. So the diameters fit here in between the curve e to the x and the x-axis. So that distance is e to the x. That's my diameter, which tells me that the radius is e to the x over 2. So now going back to finish my integration, I'm going to be integrating from 0 to 1. I can pull out the pi as well, pi over 2. And the radius of each one of these is e to the x over 2 squared dx. So now when I finish integrating that, that's going to become pi over 2. And then this is e squared over 4. So I can pull out the times 1/4. I'm basically doing integration by substitution. So the antiderivative there would be 1/2 e to the 2x. And I'm going to evaluate it between 0 and 1. When I do that, remember where we are here. We're still finishing up 8.2, number 49. We had the integral from 0 to 1. We pulled out our pi over 2. The radius, remember, was e to the x over 2 squared dx. And we had just said that that was going to be pi over 2. I can pull out the 1/4, that's the 1/2 squared. Then the antiderivative of e to the 2x would be 1/2 e to the 2x between 0 and 1. So plugging in 1, multiplying here across the bottom, I have pi over 16 e squared. And then plugging in the 0, we're going to have pi over 16, and e to the 0 is 1. So if we wanted to, we could certainly factor out a pi over 16, and then this would be e squared minus 1. Either way would be an acceptable answer, and you would leave it like that because it specified exact answers. Remember on Wiley Plus, you are typing in pi for pi. Otherwise, it's not recognizing it and marking it wrong. So be careful of reading the format that they'd like you to use.